Welcome back engineers, we are discussing architectural styles and in this video let's look at event-driven architectural style. Okay, I hope you're ready. Let's get started. So to understand this architectural style, let's take an example of an awesome jewelry store. Okay, let's say we have an awesome jewelry store and let's say we have it equipped with some basic security features. Okay, let's say there is some diamond in our store and there is a thief who's coming in probably at the middle of the night to steal this diamond. Okay, so our basic security has certain features. Let's say once this diamond is stolen, it has a sensor that detects that the diamond has been picked up from the layout, and then it will do two things. It will ring the alarm, which is good, and it will notify the owner, maybe through some SMS or email. So these are some of the basic security features, right? So this system is just doing fire and forget type of implementation, right? So it rings the alarm and then does nothing. It sends an email or SMS and then does nothing, okay? So the picking up of the diamond is an event which has triggered certain actions like ring alarm and notify owner, right? So this is what a basic security system looks like. It just implements fire and forget. Okay, now let's take a look at an advanced security system that does a little more than basic security. Okay, let's say we have the same awesome jewelry store. Our thief has entered the building, picked up the diamond, and at this point of time we have implemented a theft guard. So let's say the theft guard is a little advanced security system that does more than a few actions that we were seeing in the basic security system, right? So theft guard does certain things. First of all, it will start recording, okay, which is similar to a fire and forget type of implementation. So it just hits on start recording or calls a function that says start recording or something like that, right? So it starts recording. So all the cameras are starting to record whatever is happening in the jewelry store, and then it will notify the cops. Let's say it has some information about the nearby cops, and then it notifies them either through SMS or something like that. Okay, again similar to fire and forget, but it does something more. It starts ringing the owner and it keeps on ringing until the owner picks up and answers the call. Okay, so let's say the system is constantly making a ring. It is waiting for a response. If response is not done, then it rings again, waiting for a response, not done, keeps ringing again. Okay, so it is doing some kind of an implementation where it is keeping a watch whether the owner has really been notified or not. Okay, and it also does some other things. It keeps the doors locked. Okay, let's say immediately after the system has been breached, it locks all doors. Let's say there's a door here, exit door, it locks it. There's an entrance door, it locks it. Okay, maybe there's some bypass door, it locks it. Okay, and it locks it once and also keeps a check on the doors. If somebody else opens the door by mistake, it locks the door again. Okay, so it's continuously monitoring the doors, it's continuously ringing the owner, so it is doing some kind of a mediation in between. Okay, so this is acting like a mediator who is doing certain things along the way, and it is constantly monitoring and waiting for the right answer until it can go back to sleep saying everything is safe now, everybody is notified, and the theft has been blocked. Okay, so this is how the theft guard system works. So this is a good example of a event driven architectural style. Okay, so what is the event? The event was the diamond has been picked up and we are doing certain things after this event has happened. Okay, so this is an example from a non-tech world. In the tech world, there are plenty of examples like this. We have seen this in apps like maybe e-commerce apps like Amazon, right? So once you've placed an order, the warehouse needs to be notified. So that is like a fire and forget. But when you're actually making the payment process, there are certain things that need to be coordinated in a way that the payment is actually successful, because when you're making a payment or placing an order, it needs to do certain things. The payment has to go through, the inventory has to match, the inventory should be deducted, there should be stock available in the warehouse for that particular order, and so on. So many things need to be checked and verified before the order can be successful, right? So there is some mediation required here, right? So those are the two different types of event-driven system, right? So e-commerce is an example for such a system, right? So there are plenty of examples like this, and event-driven architecture is something that can be embedded into an existing architectural style or something that can be implemented independently as well, right? So there is some flexibility that we get with this architectural style, and it is actually quite an interesting one. Okay, now let's have a look about how this architecture actually looks like. So before we go into the features, let me actually take you through these topologies, broker and mediator. So this is the broker topology. Okay, so let's say there is an initial event that is fired, and this event is notified to the broker system. So broker systems are systems like RabbitMQ or AWS SQS, simple queuing system, and so on. So this is where the message is registered or an event is registered. Okay, and for different event types, there can be different event processors registered with the broker. Okay, so broker knows which processor to hit when a certain event occurs, right? So this event is hit and it has registered with the broker is calling the event processor, and it's possible that this event processor is calling an event internally, right? So this new event gets registered with the broker, maybe that event should be processed by event processor B, and so on. So this is a broker system, right? So the broker is just responsible for passing on the message to different event processors, right? And there is nothing else that the broker needs to do. So this is a broker topology, similar to the basic security system that we have seen in the example, right? Now let's take a look at the mediator topology. Now, similar to the previous case, we have an event that is fired, and this event is registered with a mediator now. Now, mediator is creating sub-events which are responsible for processing by processor A, processor B, processor C, and so on. And mediator is actually monitoring the processes. So let's say after this event has been given to processor A, mediator is expecting some kind of a response or some kind of an output that needs to come out of this processing. Okay, so only then that this event is deemed to be successfully processed. Okay, and similarly for processor B and processor C, if either of them fails, mediator has a couple of options now. It can either do a retry or it can do a rollback, right? So it can do a retry, it can do a rollback, or it can implement some other XYZ custom implementation depending on the use case. But the mediator is actually monitoring what is happening with the events that are fired. Okay, that is a role of a mediator. Mediator takes care of processing the event to its full life cycle and not just fire and forget, right? So that is the idea behind a mediator topology. Now let's look at the features. So the first feature is decoupled event processing. So all the event processors are independent of each other. Because of this, we get decoupled event processing. And all the events are processed asynchronously because these are external systems with respect to the message broker or with respect to the mediator, right? And this architecture can be standalone or embedded with other styles as well, right? This is a point which we have discussed before, and two types of topologies are possible. Okay. Now let's look at the trade-offs. So for the trade-off, we need to evaluate them based on the topology that is being used, because each topology comes with different pros and cons. So with the broker topology, we get these benefits. We can scale the broker topology because we can keep on adding event processors without having any impact on the system. We just need to register the processes, and then the system can be scalable. And we also get some performance benefit because there is no orchestration happening, there is no workflow management happening, so we get good performance in this case. But the cons are we have no control, we have no error handling, no restart capability, and we also have data inconsistency, because if one of the event processors has made some updates to the database and then it fails, nobody is checking this, and we have a database in an inconsistent state, right? And with the mediator topology, we get good workflow control, we get restart capability, error handling, and data consistency, which are good. But it comes with some additional complexity and more coupling anyway, because we have to take care of all the mediation possibilities and scenarios. And it is also lower scalability because we cannot keep on adding services to the mediator, and the mediator actually becomes a bottleneck in this case, because for every service that needs to be added, we need to take care of mediator performance and mediator implementation, the orchestration workflow, etc. So scalability is a little challenge here. And we also get lower performance because of all the orchestration that is happening, and the workflow itself can be quite complex in nature, and because of this, the performance is slightly degraded, right? So those are the pros and cons. So depending on the use case, we can go with either broker or mediator. If you need something like a fire and forget, just use the broker one, don't need to worry about anything. But if you need stronger workflow control, go with mediator topology, right? So this is all we need to know about event-driven architectural style. Thank you so much for watching, guys. If you have any doubts, definitely let me know. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I will see you in the next one. Cheers.